Hello, and welcome to Leveraging the Power of the Oracle Database from the Browser. I'm Scott Spendolini, the president and founder of Sumner Technologies, and I'll walk you through this session today. But before we start, a brief safe harbor statement. The following is intended to outline Oracle's general product direction. It is intended for information purposes only and may not be incorporated into any contract. It is not a commitment to deliver any material, code, or functionality and should not be relied upon in making purchasing decisions. The development, release, and timing of any features of functionality described for Oracle's products remains at the sole discretion of Oracle. Now that we're through with that, let's talk a little bit about who I am. I went to Syracuse University, graduated with a dual degree in Management Information Studies as well as Communications, and I do bleed Syracuse orange, and I'm an avid fan. If you do follow me on Twitter, you are well aware of that. Right after university, I actually worked at Oracle for about 10 years, the last three and a half of which I was the senior product manager for what was then called Oracle HTML-DB, which of course today is known as Oracle Apex. Roughly 2005, I parted ways with Oracle to found my first company called Sumner Technologies, ironically the same name as it is today. We focused on Apex solutions, training, as well as product. We rebranded to a company called Sumneva, and then were acquired by a relatively small company, about 100 employees, called Encrypting, who focused on Oracle DBA developer and Exadata solutions. Later on, Encrypting was acquired by Accenture, and after about a year or so there, I branched back out and rebooted Sumner, and again, it's still known as Sumner Technologies. I'm also an Oracle ACE director, which means that I work pretty closely with the Oracle Apex product management team, which in my case is my old manager and much of my old teammates. We provide community feedback. We advise the product team on features that we think would benefit the product, and basically act as a conduit between Oracle and the greater Apex community. Wrote a chapter in Pro Oracle Apex 4 a few years back, and then wrote Expert Oracle Application Express Security a couple years as well. And if you need to get in touch with me, there's my email address, and just as easy as my handle on Twitter is simply @sspendle. So again, briefly, we were founded in 2005, relaunched again in 2015, just a couple years ago, and we focus on Oracle Application Express, whether it's architecture, design and reviews, security reviews, health checks, education, whether it's on-site, online, custom, mentoring, even Oracle Database Cloud Consulting is in our wheelhouse. We're also the curators of the open source security tool called Apex Cert. So what we're going to talk about today isn't Application Express, but it focuses more on the Oracle database and something called ORDS, or Oracle Restful Data Services. So we'll go over the highlights of what we're going to talk about, and then I'd like to spend most of the time doing a demonstration. At the end, we'll conclude and open it up to any questions and answers. Front-end developers spend a lot of time with JavaScript, as well as obviously CSS and HTML. In almost every case, they've adopted some sort of JavaScript framework, whether it's an older framework like jQuery or something a little newer like Angular or React.js. Really doesn't matter because the adoption of a framework, regardless of the framework, is really for the same reasons. It saves a ton of time, makes coding a whole heck of a lot easier, and then it also allows these developers to leverage libraries to do things that they probably couldn't easily do on their own. For instance, with jQuery, to fade a region in and out, it's pretty easy to do. You could do it in a single command. If you were writing that, in raw JavaScript, it would take a lot longer. It would be a lot more painful. Now, frameworks are great, but they obviously have some severe limitations when it comes to managing data and securing data inside a database. However, a lot of these front-end developers have tried to take those tasks on, and time again, it gets more and more difficult, and although they may have solutions to do this, they're not optimal. So for instance, securing data access. If I just want to see records that map to my department, I shouldn't bring any other records down to the middle tier, or especially to the client, and then parse them out there. The query that runs should only return the records I'm authorized to see. Encryption is also something important. Data at rest, data in motion, everything should be encrypted end to end, where on the front end, it tends not to be encrypted because we need to see the data and interact with it. Processing large amounts of data. If you do have 1 million rows or 2 million rows, you don't want to bring all 2 million rows down. That would be devastating for the network. The client doesn't have enough horsepower to process that. You need something in the back end to help you, to assist and say, of these 2 million rows, here are the 10 that you want. And then lastly, maybe the 10 that you want aren't just simple searches. Maybe we need some sort of analytic. I want to see the top 10 paid employees across 10 different departments. Or I want to see how much more somebody makes than the next highest paid employee in any department or in a specific department. So complex analytics is definitely not a good front-end activity. So let's shift gears just a little bit here and talk about something called data longevity. And I know this has very little to do with front ends, but it all ties together in just a couple slides here. Think about your organization and how long they've had data. If you've been around for 50, 60, 70, 100 years, your first customer was probably written in a ledger. If you're a newer company, maybe 10, 15, 20 years, your first customer record was probably put into a database. The interfaces and the technologies used have changed over time, dramatically in some cases. So let's not go back 100 years, but maybe let's go back 30 or 40 years. Mainframes. Many people who've had businesses that have been around for 30, 40 years or so have used mainframes. In some cases, they still may be using mainframes to store their data. The interface was done on these little green screens, these VT terminals, all text, and if you were lucky, maybe you got an amber one. As technology evolved and PCs dropped underneath that $2,000 price point in the 80s, you can get this really slick dual 3.5-inch drive IBM PC and run DOS-based applications. Still character mode, but with the advantage of multiple colors. Enter the 90s, and something called client-server became tremendously popular. The idea here is you'd install a whole bunch of stuff on the client as well as on the server, and when those two pieces of code or chunks of code ran, they'd interact with each other. So the server didn't have to do all the heavy lifting. The client could handle much of the interface as well as some of the initial validation and even business rules. And then we have the web, which is essentially where most of our technologies are being deployed today. As the web got more powerful and browsers got more capable and internet speeds increased, we turned to building HTML-based applications, which again is how most systems run today. One caveat is we also have a mobile realm. Mobile first, I'm sure it's a term that almost everyone's heard, is that companies and organizations are trying to push out their applications to mobile devices. It could be a native application. It could simply be a responsive HTML application. But today, we tend to live in that web and mobile space when we build anything new. Think about now how many updates you would have to do to update what are largely the same business rules over all these different technologies. So you'd have to write it once for the mainframe, you'd have to rewrite it for MS-DOS systems, you'd have to rewrite it for client-server, rewrite it again for the web, and then rewrite it yet again for mobile. The data hasn't changed. You still have customers, you still have orders. The business rules probably haven't changed a lot, but definitely have had some enhancements to them. And that had to be done over and over and over and over again. So back to the front end, we're in this space, right? We have a challenge where front-end technologies are going to continue to change. They're going to evolve at a much more rapid pace than what we just saw. That last slide spanned over 40 years. New frameworks get released almost daily, it seems. Data security and management requirements today are much more sophisticated and much more important than they've ever been. There's laws today that didn't exist 10, 15 years ago that dictates how data needs to be stored and managed. And at the end of the day, as front-end developers, there's only so many hours in the day to do all this stuff. We already have challenges to build the front end, to build the validations, to build the user experience. So your challenge is difficult. How can you assure that your data is being managed properly, given that you have all these different things to worry about and a constant flux in your tool set? One answer here is obviously the Oracle database. This is a tried and matured platform that's been around for over 30 years. If you wrote business rules maybe 15 years ago, 20 years ago in PL SQL, there's really not a lot you'd have to change over time as far as would they still continue to work. Sure, the rules would change and they need to be updated, but those core business rules would have survived all these different technologies. So Oracle is a very stable and a very low risk choice for front-end developers who need a place to securely manage your data, to put their business rules in and not have to worry about changing it as you go from technology to technology, or in your case, from framework to framework. If we take a look at that slide again, Oracle probably came into the picture, give or take, around the character mode side of the MS-DOS systems, perhaps on the client-server side, depending on when your organization adopted it. So Oracle's kept pace as well. Oracle Forms Character Mode was one of the first development tools that Oracle released that did run on DOS machines. As client-server became more popular, Oracle Forms Client-Server came out, and developers were able to use rich interfaces and build nice-looking apps that ran in Windows. As the web became more and more popular, tools like Oracle Application Express, ADF, or Portal basically gave data in an Oracle database an easy path to be displayed securely and scale quite well on a web page. And now, as we're in the mobile era, Oracle Apex, being a responsive system, or the mobile application framework toolset, allows us to build native applications on mobile devices running on top of an Oracle database. So if we look at the world through a slightly different lens and understand that these frameworks are changing a lot, they're developing at a much faster pace than we've ever seen, Oracle can still fit underneath everything here. And using tools such as the ORDS listener or the ORDS service, which is the Oracle Restful Data Services, we can provide very easy access to the Oracle database, yet secure it in any way we deem necessary, so that front-end developers have little difficulty building their applications on top of the Oracle database. Now, one thing that a lot of people are worried about when they hear the word Oracle database is the high price that comes with it. This isn't always true. So let's talk about a couple different ways that we could run Oracle. On-premise is probably the most popular way. It's been going on that way for years now. You could run Oracle in your data center, on your servers, have complete control over everything. But obviously we're in the cloud era now, and Oracle does provide a fully hosted cloud-based version of their database that you can run. Easy to set up, takes just a couple minutes to configure, and you're up and running. Third parties also offer Oracle cloud-based services, such as Azure as well as Amazon Web Services. Cost in the cloud is also a lot less than most people assume. And I'm not going to go through all the different pricing options here, but suffice to say, you could get in the game for as little as $175 a month using the Exadata Express service, which is what we're going to use for the demonstrations that we'll be starting here in just a second. So for the demonstration, we're going to build a pretty simple web application that does some pretty sophisticated things on the back end. To start, we're just going to do some pretty simple queries. We're going to pull the data up and display it on a page. We'll use jQuery, and the reason why I picked jQuery here, it is an older framework, but most people are relatively comfortable with it. And you could take the simple HTML files that we're going to use and adapt them to really any framework you'd like. We're also going to use Oracle Jet, which is called the JavaScript Extension Toolkit, to do some visualizations. So you'll see a chart on our web page as well. That's all being rendered via the Jet libraries. So the first thing we'll do is we're going to connect to our database. We'll create some sample tables and put some data in them. We're then going to create the necessary web services using ORDS. We're going to do that through a tool called SQL Developer. We'll then create some simple HTML reports and forms that interact with those web services. And then lastly, we'll turn on all the different database features. Once we get to that point, all of the changes of this application are going to be done on the back end. In fact, once we copy and paste the HTML pages, we're done making changes there. Everything we do from a functionality and a business rule point of view will be managed on the back end. Again, minimizing what you need to worry about on the front end and letting the Oracle database do the heavy lifting. So for this demonstration, I'm going to use the very tried and true legacy perhaps demonstration objects called EMP DEPT. For those new to Oracle, these tables have been around forever. They're very simple. EMP has 14 records, DEPT has 4 records. but they're sophisticated enough and elegant enough in their simple design that you could do a lot of complicated type queries with them. And a lot of examples are on the internet. If you wanted to search for Oracle examples, EMP and DEPT, you'd find lots of different documentation using these tables. For those who've been using Oracle for a while, this should not be anything new. You've seen these tables hundreds, if not thousands of times. So, as I mentioned before, we're going to use the Oracle Exadata Express cloud service to conduct all the demonstrations here. It's quick and easy. If you want to request a free trial, simply navigate to the URL underneath the last bullet point here on the slide, and you can be up and running with your own personal PDB or pluggable database in just a few minutes. So let's jump into the first demonstration. I'm running Oracle SQL Developer, which is Oracle's free IDE for the Oracle database. You can see here I currently have 2 connections, PDB admin and one called Scott. Again, for those new to Oracle, I'm not using Scott because it's my name, but Scott is one of the original demo schemas, so it's almost second nature to me as I've been using this for almost 20 years or so. So PDB admin is more of an administrator account. Again, we're running in a PDB or a pluggable database on an Exadata machine. So this account is going to give me privileges to manage things. I'm going to go ahead and connect to it, and all I need to do is click on that little plus icon. It's going to use the credentials that I've already stored, and it's going to make a secure connection to the database. And in just a second, we'll see a window that will allow us to interact with the different objects in the PDB admin schema. If you look now on the left-hand side of the screen, you can see all the different object types that SQL Developer supports, from tables to views to indexes, packages, etc. What we want to do here is create our demonstration user. We don't want to use the admin user for the demo. We want a brand new user. So I'm going to go ahead and open up a script called scott.sql. And then if I click execute here, what we're going to do is run this entire script as the PDB admin user, and it'll go through, drop the user, recreate the user using a table space called DB Cloud. It'll then allow me to create database objects by granting an unlimited quota. I'm going to grant create session and resource to this user, which is going to allow it to also have privileges to connect to the database, as well as create common database objects. And then over here, the next 3 grants, dbms redact, dbms rls, and dbms fga. Each one of those grants does have to be made by an administrator, and those will give me access to different security features of the database. We'll get into that a little bit later, but suffice to say, these commands need to be run if you want some of the later exercises to work. Now that I have Scott created, I'm simply going to minimize my PDB admin connection and open up my Scott connection. And it'll take a second or two here as it connects to the database and verifies its credentials. And once that does connect, I'm going to run a script. That script is essentially going to create 2 tables and then populate those 2 tables with some data. So this time, I'll go locate a script called emp.sql. Notice I dropped those tables first, just in case they existed. Then I create the depth table. Then I create the emp table. And if you scroll down enough, you'll see all the different records we're going to insert into those tables. Again, anyone who's used Oracle for any amount of time, this is very familiar. Those that are new, this is basically some of the standard data demonstration tables that Oracle uses. So I'll go ahead and run the script, but this time not as PDB admin, but as Scott. And you'll see it'll go through, insert all the records. And to double check on things, even though I didn't see any error messages, I could always navigate to one of the tables, click on the table name, see the definition of the table, but also click on data and ensure that there were actual rows inserted into the table. So it looks like we got our 4 departments, and if we click on emp, my guess is going to be we're going to see all 14 employee records once it queries the database, and there they are. Next thing we're going to do is create the web services to expose the tables that we just created. And we're going to do that using ORDS, or Oracle Restful Data Services. This product used to be called the Apex Listener way back when, but it's been recently renamed to ORDS because Apex is not a requirement to use it. It is a fully supported product that has been associated with the Oracle database for 7 years now. You can log SRs against it as long as you have a corresponding database CSI. Really what ORDS does, and I know there's a lot of acronyms in this sentence, is it maps HTTP RESTful gets and posts to SQL and PL SQL. What that really means is it's an interface layer so that I can write a very simple or perhaps sophisticated query in SQL and have ORDS translate that into either JSON or CSV and hand that back to whichever client is calling it. Whether it's a Java application, a React application, jQuery, HTML, ORDS simply doesn't care. It'll go ahead and produce that document and hand it off based on which resource is requested. So this gives us the ability to basically securely web enable any Oracle database within just a few minutes. So a basic architecture slide here. Again, we've got our client, which makes a request. ORDS maps and binds that to a SQL statement or perhaps a PL SQL procedure. That'll go query the database, assemble the results just like any other SQL query, and then ORDS does all the transformations for us. So in this case, it'll hand back a JSON document, which we can then do as we please with. ORDS is a Java application, so it does currently need an application server, and it's certified with Oracle WebLogic Server, Glassfish, or Tomcat. In a future release, 4.0, ORDS will also have Jetty embedded in it, so you don't even need an application server. But as it stands today, any one of those three works just fine. So we'll use ORDS next, in the next part of our demo here, to create a few web services that'll be consumed by our HTML page. We're going to get a list of all the employees, so we're going to query all those employees out of the EMP table. We're also going to create a web service to get details for only a specific employee, because we're going to want to edit one record, not any arbitrary record or all the records. We also want a web service that's going to allow us to make updates to an employee, perhaps change their job title, change their commission or their salary. And then lastly, we'll have another web service that gets a list of departments that we're going to use for our select list when we edit employees. ORDS does support security via OAuth or basic authentication. We're not implementing that in this demonstration just as an interest in an interest of time, or lack thereof time in this case, but it does have full support to produce secured web services. So let's go ahead and create those web services in ORDS. And again, we're going to use SQL Developer to do this. As a first step, before I do anything, what I want to do is enable REST services on the schema. And in this case, it's the Scott schema. So I'm going to go ahead and click Enable RESTful Services. It's a really good idea to not expose the name of the schema through the URI that we're going to create. So in this case, what I like to do is just call it DB or something, not the name of the schema. While that in of itself isn't a security risk, it does give a malicious user or a hacker some information about what the schema name is. And while they can't do much with that, that may be very beneficial elsewhere for them. So we're not going to give them anything that they don't need. We're not going to worry again about the authorization, so I'll uncheck that box and hit next. Basically, we get a summary of what's going to happen here, and I'll hit finish. And you note that we get a success message, successfully process SQL command. So our schema is now ready to be ORDS enabled. So the next step we need to do is basically scroll down and find the REST Data Services node in our tree and expand the modules node. There shouldn't be any modules here. This is a brand new schema with no information. So what I'm going to do is right click it and select New Module. This will pop open a wizard that I'm going to go through and specify a couple different options here. We're simply going to call the module name as well as the URI prefix that I'm going to refer to this in the URL, demo, just to keep things simple and easy to remember. I could choose whether or not I want to publish this and make it available for use. So if I was just building it but I didn't want anyone to use it yet, I could simply unselect publish. But in this case, we do want to publish it. We'll hit next. For the URI pattern, what this is looking for is the actual thing it's going to call, right? And this is usually named after the object or the table or the view that the web service refers to, although you're free to call it pretty much anything you'd like. In our case, we're going to simply call this EMP. And as you see here, the URL, ORDS MySchema demo EMP becomes our URI. We'll take all the defaults for priority as well as the entity tag. We get another summary screen here, and I'll go ahead and click Finish. And we get another success message. And notice in our tree, we now have an EMP template underneath the demo module. What I want to do next is add a handler. This is where we decide whether it's a get, post, put, or delete, or what mechanism we want to use or method we want to use. We're going to keep this one to a get because this is our basic query for all employees. And I'm going to basically select query here. I could return CSV, but in this case, we want to return JSON. I'll go ahead and hit apply. Where we are now is we've got a worksheet where I could write the query that I want to use for this web service. So I'm going to go in the document here, I'm going to select the SQL, and I'm going to paste it inside this worksheet. Now we could run it here to make sure that there are no errors. And as you can see, we're kind of selecting all the different employees. Right now, we're hard coding in the salary difference column. We're going to use that later. We're also looking for commission and making sure that if there is no commission, we just simply display a 0. And then we're joining the EMP and the DEPT table on the common key, which is DEPT no. You can see the results are all 14 records with the column headings in place. Once that works, we're going to go ahead and click on the save icon. And we now have that method set underneath the EMP template, which is part of the demo module. At this point, we may want to test this web service out. And in order to do that, because it's a get, we can actually get away with using a browser. I'm going to go ahead and switch over to Chrome. And what I'm going to do here is simply paste in the URL to our web service. Again, I've got my Exadata Express server name here. Apex being the next piece of my URL. Really depends on how the server's configured. It may be Apex, it may be ORDS. DB is the alias that we created when we actually created the first module. Demo being the module name, and then EMP being the template. Because this is a get, we don't need anything else on the URL. I could simply hit enter, and in a second or so, we'll see a JSON document with all of that data. Now this is a little difficult to read. I'll be the first to admit that. So you may want to use a tool such as Postman. Postman is a free tool that allows you to basically test web service results. And what I mean by that is if we run that same get, Postman is going to display it in a much easier to read format. We could also see the raw format if we were looking for something specific that dictated us use that view, or if this were some sort of HTML rather than JSON, we can get a preview of what it might look like in the browser, typically without any style sheets tied to it. But we're going to stick with the pretty view here and understand it already detected that it is a JSON document. So our first web service is working just great. Let's go ahead and create the next couple so that we can get over to the HTML page as soon as we can. So the next one we're going to create is going to be very similar, but this one is going to be for the DEPT table. What we're going to do is create another template under demo. And I'm going to right click and select add template. This time we'll simply call it DEPT, hit next, and hit finish. We'll then right click and add another get handler. This is also going to be a query. And I'll go ahead and paste in the simple SQL statement that we're going to use for the DEPT table. Let's test it first, and it looks good. I'll go ahead and save that. And then just to be thorough, what I want to do is come back over here to Postman, switch this to DEPT, and make sure that it is in fact working, and it looks like we're in good shape. The third web service we need is going to be slightly different. So what we're going to do here is again create another module, another template, excuse me. And we're going to call this emp / curly bracket emp no. Curly bracket. That denotes to ORDS that we're going to pass in a parameter here. So we'll go ahead and finish this web service. And just like we've done in the past, we're going to add another handler. It's going to be a get. This time it's going to be query one row rather than a query that returns multiple rows. And I'll grab the SQL here, paste it in. When I run this, it's going to error because we've yet to define this variable, empno. So we need to set a parameter for this query to work. And it's pretty simple. Click the plus sign, enter empno as the name, empno as the bind parameter. It's an in method. It's going to be part of the HTTP header. And in this case, we could select this to be integer since we're passing in employee numbers. Once we save the web service reference now, and we go ahead and run this, it still doesn't work. So this is where Postman is going to come in handy and help us out here. I'm going to switch over. I'm going to grab the URL that we used for the original employee query. I'm going to create a new request. But this time, I'm going to include 7839, which is one of the employee IDs, and run my query now. Notice that we get back that specific record. We're not getting back all the records anymore. We're just getting back one. If I were to do 7788, which is another ID, we would get back a different record. So that web service is in fact up and running. Let's add one more web service that we're going to use as the source for the chart. So if we navigate back to SQL Developer, I'm going to create another template. And the name of this template is going to be Sal by job. We'll hit next. We'll hit finish. And then of course we'll add a handler called of type get. This will be a query. When I run it, you can see here it's actually simply producing the job name and then the sum of all the total salary for that specific job. So we don't need any more parameters or anything on this one. This one's pretty basic. We've gone ahead and saved it. Again, let's just make 100% sure that it's working. We'll copy this URL, open up a new one, and then Sal by job should return a couple different value attribute pairs, one for each job. Now we've got 4 get-based web services, and each one of these is fetching data. We do, however, need to create a web service to send data back so that we can update our employees. We can actually reuse this template here and simply create a new handler. In this case, we're going to create a post handler for the EMP template. The MIME type that we want to be able to work with here is going to be JSON. So application/JSON will be our MIME type, and we'll hit apply. What we could do now is write a little bit of PL SQL that's going to basically update the record based on the values that have been submitted. So if we look at our update statement here, it's going to update emp, set sal equals sal, depno equals depno, etc., where the employee numbers match. So we've got to create at least one parameter, and we've done this before. empno, oops. And this will in fact be an integer, but the truth is we've actually got to create 5 additional parameters so that we can handle all the different values being passed in when we post that request. So the next one we need to create after empno is ename, and that will be a string. Depno, the department number of the specific employee, will be an integer. Sal for salary will be an integer. Com for commission will also be an integer. And last but not least, job title essentially will be a string. And we'll go ahead and save that. So now we've got both a get and a post on emp. Switch back over here to Postman. We need to change Postman just a little bit in order to test this. So I'm going to grab that original URL, pop it in here, but set the get to a post. What this is going to allow us to do is specify different values that we want to update. So in fact, empno will be 7788, and we can pretty much go back over here to see a specific employee. So department is 20, name is Scott, salary 3,000, etc. Next, we'll do depno 20. Sal was 3,000. Com was 0, and then ename was Scott, and job was analyst. Now what we've done here is basically map the same values that already exist. So if we were to send this, we shouldn't notice any difference. But let's change it up a little bit. Let's give him a $100 commission. Verify that there is no commission here. I'm going to go ahead and click send now. And then I'm going to rerun this web service here, and we should see that the commission has been increased to 100. Just to prove 100% certainty that this did work, if we go back to the EMP table and select the data tab, find the Scott employee, and you'll notice here that the commission has in fact been set to 100. So all of our plumbing is working. Our web services are set up. At this point, we don't need to make any more changes here. What we're going to do next is configure the HTML file that interacts with these web services. So the front end is going to consist of two HTML files and a JavaScript file. One HTML file is the report, which will contain the visualization that makes reference to the JavaScript file, and the other one is the form. We're going to use jQuery, as I mentioned before. Pretty basic. Any front-end developer who's been around for a while has probably used it at some point, and it wouldn't be too difficult to basically adapt these HTML files to use any popular framework. Now, Oracle Jet is going to be a piece that we use for the visualization. This is a relatively new open source JavaScript toolkit that Oracle provides for free. It gives a lot of components that you could use for SPAs or SPAs or single page applications, built-in accessibility support, which is more and more important these days, as well as a rich set of UI components. For more information on Jet, simply visit the URL listed here in the slide. So let's take a look at our HTML files, and then we'll load them up in Chrome. The first one, RPT, is basically the report. Notice at the top we've got a few references here to JavaScript libraries and whatnot, but for the most part, we're calling this getJSON call, and we're referencing the first web service, the EMP web service that brings back all of our records. Down here a little further, we have the reference to the container that's going to contain our visualization. The form HTML, again, has a bunch of configuration details and a couple APIs. It also has a select list, which gets its source from that DEPT web service that we created. And then down here at the bottom, you'll see the post action that also references the EMP endpoint that we created. So as we see the records, we can make changes to them and then send those results back to the database. Lastly, chart.js is simply a JavaScript library that also has a couple different references. In this case, sal by job is going to be the JSON document that it uses as its source, and the rest here will simply feed back the JSON, and then we'll generate the pie chart. So let's go back over to Chrome. And what I'm going to do now is open that HTML file. So I'm going to locate it in our demo folder. Here it is, rpt.html. And once I open it, you're going to notice that the data gets populated from the database, as well as the pie chart gets populated based on the salary summarization report. If I look at any of these employees, let's take a look at 7788 and hit edit, it'll pull those records out of the database. And if I were to say, let's move Scott from research into sales and reduce his commission back down to 0 and hit save, notice that Scott, even though he's an analyst, is now in the sales department and has a commission of 0. So it looks like all the plumbing is working. Our standard static HTML files do in fact display the data, and we can edit records, make changes, and have those records impact the database. Next, let's add some database features to change things up. From here on out, we're not going to touch the HTML. All we're going to do is make slight changes to the web services. So we're going to do 4 different things. We're going to create an analytic function or use an analytic function. We're going to use Oracle's redaction feature. We're going to use virtual private database, and then we'll turn on auditing. So analytic functions are pretty powerful things. What these do is compute aggregates which return multiple rows. So for instance, rank and dense rank. Of these records, rank them in order, and then we can partition those ranks, say in this case by department. First value and last value. So give me some data sets, but I want to know the first and the last value of those data sets. Lag and lead, right? So give me any row in any data set and show me the row right before it and show me the row right after it. Lots of power that these analytical functions provide for us, and they're very easy to use. So let's go in to our web service, and the one we want to look at here is the EMP DEPT. So if we select that in SQL Developer and select Edit, we'll see the query that we had in here before. We're going to change that query ever so slightly so that now, instead of having rank as simply 1, 2, 3, 4, 5, we're going to rank partition by the department number, and we're going to order that by salary descending. What this means, if we run the query here, is we now have all the accounting department employees ranked from the high salary to the low salary. We then go to the research department and rank all their salaries from the high salary to the low salary, and for each department that iterates through. All I have to do is save this and flip back over to Chrome and reload the page and watch how rank changes from 1 to 14. Now we see 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 5, 7, because these two were the same. They're both ranked 5, but of course the last value gets ranked 7 because there's 7 rows in the data set. All that power from one single change, one simple single change to our query. Another function that we could use here is the lag function. So if you notice now, sal diff doesn't really change, and we hard-coded that to 0 initially on purpose. If we go back over into SQL Developer and paste in the next query, what we're going to do here is get the previous salary, subtract that from the current salary to determine what the difference between that person's salary and the next highest paid person's salary is. If we run the query here, whoops, there we go. You'll notice now salary difference here, 5,000. Well, the difference is 5,000. It's the first one. But the next salary of 2,450 has a difference of 2,550. The next one of 1,300 has a difference of 1,150 because it's looking back one row and one row only. Then we go to research and we repeat the process. Once we've saved this and now we've got our second analytic function in place, reloading the page will now display those values in the sal diff column. Again, no changes done to the front end. All the changes are being done on the back end here, which makes it a lot easier to manage, a lot more powerful, and a lot faster because the database is doing the heavy lifting. We're not relying on any client-side library to do that. Redaction is another security feature of the Oracle Database 12c, but it's also available in 11.204. What redaction does is it masks sensitive data returned in queries. We could do full redaction, which hides all the data altogether. Partial redaction, so for instance, if we wanted to only show the last 4 digits of a credit card number just to verify with the customer it's the proper card, we could use a regular expression to do some pattern matching and only redact parts that match the pattern, or we could do random redaction. In our case, we're simply going to do full redaction on the commission column. So if you notice here, we've got 3 employees who are currently receiving commissions. Once we turn on redaction, we're not going to change the data, but we're essentially going to redact that data when we run it through this report. So I'm going to switch back over to SQL Developer, And this time I'm going to go to my SQL worksheet here for the Scott user. This opened up when we originally connected to the schema. And I'm going to go ahead and run dbms redact add policy. We're going to redact the EMP table in the Scott schema. The name that I'm using is simply arbitrary. I called it redact com, which is redact commission. Our expression to run this is 1 = 1, meaning always run it. And the column name that we want to redact is com. The type will be full. So in this case, because it's a number column, every value will be 0. Let me simply run this dbms redact add policy command. And as soon as I flip back over and requery our table, notice all of the commissions are set to 0. Again, back-end command, very simple. It's going to work everywhere. Even if we edit a user that we know had a commission, the redaction is still going to apply at the form level. The next thing I want to talk about is something called Virtual Private Database. This is a security feature that allows you to filter data based on predefined rules. Typically, we use this to filter data based on whether or not a user has a role, is a member of a department, has some sort of access privilege. We apply a VPD rule to a table or view, and then any transaction that ever touches that table or view will have the VPD function applied to it, regardless of where that transaction originates from. This is the proper way to secure your data because you only have to do it once. And if you remember back to the slide where we talked about the evolution of different technology and interfaces, had you done VPD way back when with Oracle Forms, as you migrated to client-server forms, to the web, to iPhone or Android-based apps, all your VPD rules are still in place and are still respected. So what we're going to do, this is a two-part demo here, is we have to create what's called a policy function. The policy function is the little bit of business rule that determines what we want to append to the query when the VPD rule is invoked. So again, we're going to use our SQL worksheet here, and the function is going to be pretty basic. We're going to restrict what we see by department. In this case, we're simply hard coding in department number equals 30, but this could be dynamic and look up which user is connected to the system, what their department is, and then fill in that value so that users will only see data within their own departments. Let's go ahead and run this and create the function. Now that only created a function, and this function is nothing special. It's not unlike any other function. Until we register the VPD policy, it simply won't do anything. Just like redaction, we're calling dbms rls.addPolicy. We're putting it in the scott.emp table. We've given it a name, restrict by dept. We've referred to our function, restrict by dept. And in this case, we're only going to worry about select statements. So let's institute that VPD command. When we go back and look at our data set now, I'm going to requery it again. Notice that we only see the records from sales. Notice over on the right-hand side, we never talked about the chart. We never talked about the web service that the chart uses. But because that web service touches the EMP table, the VPD rule is in effect. If we edit an employee, it should work just fine. But if we were to go over and say 7839, we know that employee exists, but we're not seeing the record because VPD is simply returning no values. So it's doing its job, and it's doing its job well on the back end, close to the database where the data resides. Now, as a last security measure that I want to talk about, something called auditing. Pretty simple. We could enable auditing almost anywhere in the database. Oracle Database 12c makes it even easier using something called unified auditing, where you don't have to create more complex rules. You basically say, I want to turn on auditing for a specific table, and I could even include conditions now. So don't audit every transaction. I really don't care how the system's running day to day, but I do care if someone's updating a salary above a certain threshold. Or I do care if the IP address is not one of my internal users, but is an external user. So let's add that one last piece here, which is the call to turn on auditing. And we'll do that through SQL Workshop as well. We'll go ahead and paste in DBMS FGA for fine-grained auditing, add policy. Same thing, scott.emp. We're going to call this web service, and we're going to monitor inserts and updates only. We don't care about selects. We only care when the records change. When salary exceeds 4,000 is our trigger, and the column that we're watching for that is going to be Sal. There we go. And now if I switch back over, and let's edit Scott and give him a nice raise of $5,000 and hit save. Nothing changes here. We see the salary is now $5,000. But if we were to query the unified audit trail, which we do have to do from the PDB admin user, so let's go back over here and paste in select star from unified audit trail, where the policy name equals web service, and we'll sort by the timestamp descending. We'll run this query, and the top result should be the transaction that we just instituted once this query comes back. And if we take a look at the host here, it is coming from oraclecloud.com. As we tab over, we can see that it did use a database username Scott. ORDS public user is the proxy username, which is going through the ORDS server. Apex listener, again, we said that's the old name for ORDS. It's still a little bit of legacy name in the tables here. But as we scroll over, we're eventually going to see the actual SQL that was run. And there it is. Update emp set sal equals :B5, so a bind variable. And you can see that the bind used was in fact 5,000. So there's your first bind. It did audit that transaction. So as an administrator, as a DBA, we could turn this on perhaps on all of our web service interactions, or only those that exceed or have some sort of value, so that we could be aware of what's occurring on our system very easily without having to build our own audit infrastructure. Why build your own? There's already a very robust, easy to use, easy to manage infrastructure for auditing that comes with the Oracle database. To summarize here, we're all aware that front-end developers have all kinds of change, more than enough change in their lives, to be concerned about things like whether or not the function they wrote works right, whether or not the security routines that they implemented are going to work when the database scales up. Oracle can provide all these different utilities: business rules, data management, security, etc. It can store them efficiently, it can store them securely, manage and maintain any size of data set, and only return those rows that are necessary for the end user, and provide all kinds of enterprise class security features. Any security feature that you've seen with any Oracle presentation, for the most part, will work when implemented in this manner. At this time, if there's any questions, we'll be happy to address those. I'd like to thank you for taking time and spending it with us today to learn more about how you could leverage the power of the database through your browser. Thank you.